Okay, a few practice problems for you. This one, I've given you two sides, although it doesn't look like it. If I put an over 1 here, you might see it a little better. And then if I write it like this, you might like it even better. I don't know the angle, but I can draw the sides. I'm going to always, when I have variables, do it in the first quadrant. So cosine is adjacent over hypotenuse, and this side must be square root of 1 squared minus x squared. Some of you might be like, but you did it backwards the other time. Well, this one, the 1 is the big side. We know the 1 is the bigger side because it's the hypotenuse. Did it stop working? Oh, good. Okay. All right. Can you guys teach the next person? I'm pausing for a second. Okay. So, final answer for this one is tangent of this angle. That doesn't look like an angle. It is an angle because that's saying I want you to find an angle for this. When it's got an inverse, that means you're going to get an angle answer. So then this is tangent of an angle. That's the angle. Tangent is TOA, is opposite over adjacent. That's this over this, which is square root of 1 squared minus x squared over x. There you go. Do you want more that have variables, or do you feel like you've got those down? Opinions? Yes? A little louder.
On the one we did before.
Yep. The one we did before. Oh, yes. Okay. I get what you're saying. The why didn't we draw this in other places thing. I get that. In this one, there was no inverse, and therefore, obviously, you could theoretically draw this in a lot of places. But my advice to you is, if there's variables, just always do it in the first quadrant. Here's why. Because I can put in a negative in for the x, and it handles the fact that it could be in other locations. You know what I mean? Like, if I drew this in another spot, I'd get the exact same answer, except with a negative. But do you get if I put a negative here and then there was another negative in the variable, it would just cancel it out anyways? So, bottom line, you only have to do these in the first quadrant. I get, you know that there's a lot of times two answers, but not when there's variables, there's only one. Okay? All right. So let's move on to a different kind. Circle trig again. I like it because it's so important. I think it was our chapter 12 test, and we've used it on almost every test after that. And it covers so much stuff. So I know we even talked about this yesterday, but if sine of some angle is root 3 over 2, and tangent is greater than 0, then what's the cosine of that angle? It's all about drawing triangles in the right spot, knowing where things are positive and negative, knowing when there's two answers or only just one. All right, so I'm going to pause for a second while you try this. Okay, first up, sine is positive. You know why I know? Because it doesn't have a negative over there. So if sine is positive, I'm going to go, all students take calc. Sine can't be here. Why did that, weird. I don't know why it won't erase this A, or this thing right there. Put the A back in. Okay. If sine is positive, it has to either be here or it has to be there. Now, why don't I get two answers at the end, though? Because they said tangent was what? Greater than 0, which rules out this spot, because tangent would be negative there. And since tangent is greater than 0, I had to be on this triangle. Now, I'm going to do opposite, hypotenuse. That's going to be a 1. And I've got, I think that's right, isn't it? Double checking. 1, 2, square. Yep, that's right. So then this is a 60-degree angle, also known as a something pi over something. 1 pi over 3, or just pi over 3, yes. Any questions on that one? Did I finish the question? I had a lot of people like looking at the board like, what? You should just say something. I said the answer is pi over 3. Is that what they asked for? No, what did they ask for? Cosine of the angle. Well, cosine of pi over 3 is the final answer. You don't have to go draw a new triangle. You got one right there. And cosine of that angle, which is 60, which is pi over 3, cosine of that is adjacent over hypotenuse, which is 1/2. Final answer, 1/2. There we go. Okay, so there's just a quick review of some circle trig. It's going to be a little intense, but if you keep on doing these problems with me, I think it's going to really help you. Next one. In the sinusoidals, this kind of thing, do you get that there's an amplitude in there somewhere? Label it. Do you get that there is a, you know what? I'm going to change this a little bit. This actually matters a lot. I'm going to put the 3 inside the parenthesis. You might think that doesn't matter, but it totally does. Does it change the amplitude? No. What was the amplitude? 4. Does it change the shift in the upward direction? No, that's still a 7. Doesn't matter whether the 3 was in there or not. What does it change? Well, it's still the B, actually. The B is 3 either way. This is considered A. This is considered B, whether it's on the inside or the outside. That's B. Then what did it change? It changed that. What? How did it change that? Because now we could factor this 3 out. And what would we have left? Theta minus pi over 3. Very good. So why do I care? Because if I asked what the shift was, it's also known as the phase shift, you should say the phase shift was negative pi over 3. The phase shift is not just pi. A lot of people think it's just pi. Nope. You have to factor it. Remember I say if you can factor it, you should? Another case. Got to factor that puppy. So the phase shift, in this case, would be right pi over 3. Okay. So that's enough about sinusoidals. Let's see, what else do you have to know? Okay. What was r comma theta from? Ooh, that's polar. We haven't talked about polar a bit. All right, pausing for a second. Okay. So if it's r comma theta, what if I tell you it's 7 comma pi over 6? Well, what can you even do with that? Well, you could graph it, and why would you want to graph it? Because then you can find its rectangular coordinates. I know that polar kind of looks like this. This is my r, and this is my theta, and I can put a dot there. But there's a rectangular way to get there too, over and up. Okay, this is not the right drawing for the one I gave you. But make a drawing kind of like that for 7 comma pi over 6, and that'll help you figure out what the rectangular coordinates for that are. All right, so I got it partially set up here. Maybe from here you can figure out what x and y are. Okay, so I personally would set it up this way. I like these helper triangles. And this would be the 1, 2, square root of 3 triangle. Because then once I got that set up, I can do this little deal. X is to root 3 like 7 is to 2. I'll say that again. X is to root 3 like 7 is to 2. And then you can solve it. Multiplying both by root 3. This x was to root 3 like 7 was to 2. So I'm going to go root 3 here and root 3 here. Cancels. 7 root 3 over 2. Okay. Same kind of deal on the y. Y is to 1. Ooh, that's going to work slick. Like 7 is to 2. So there we go. Half of 7. Also known as 3.5. Okay, there. I got my x and y coordinates. Another thing on polar. Do you remember on polar, if I had a spot here, let's say that's a 45-degree angle. Give me 1 second. And let's say that spot is at, let's say 5. This would be r comma theta, 5 comma 45. Do you remember the deal where you could have a negative r? What is the way to say this one as a negative something, comma something? Hint, it has to do with finding a different spot and reflecting it over. Pausing. Let's see if you remembered this deal. You go across over here, and you figure out what that point would be. Okay, so then I'm going to make this and say that's a 45-degree angle then. And then you go, okay, what would that be? That would be a whole bunch of 45s. I guess you could think of it as a whole bunch of pi over 4s. So did you get that this spot still has a radius of 5? So it would be 5 comma, and then a whole bunch of pi over 4s, 5 pi over 4. Did any of you figure that one out? Awesome. That's kind of like the shadow point. Then you bounce that back to the original and say, what if I want to reflect this point over to there? Then it would be negative 5 pi over 4. So remember, the first thing you do is figure out where the point is on the opposite side of you, and then you bounce it over here by making its r negative. How many of you would benefit from practicing that one more time? All right, several hands, so we'll try that again. So let's say we had this spot, and it starts here at r comma theta. Let's make the r 8. And the theta is, no, not negative, it's 3 pi over 4. That's where this is. Remember, these aren't a line, they're just a dot. The line's only there to help you find this dot right here. So then the question is, how could you write that as a negative 8? Well, you don't just say negative 8, 3 pi over 4. That'd be way too easy. That's not it. But how could you write that with a negative 8? You got to find the shadow point. I'm going to pause for a second while you give that one a try. All right, so you should be able to do this with negative angles too. That's a good point. This could go around and be a negative angle, but what was asked on this one was, what if you wanted to have r be negative? Okay, so then I got to find this shadow point over here. And that would be also at 8 because I just make it be 8. But then how do I get there? I'm going to use a negative just to show you can. That would be negative, well, what's that angle? If this is 45 and this is 45, then I could say negative 45. So this spot right here would be 8 comma negative 45, also known as negative pi over 4. So then to take this spot now and bop it over here, I need to make it negative. So then it's negative 8 comma negative 45, also known as negative pi over 4. Now, some of you are like, but I didn't use a negative. You didn't have to. If you used a positive angle, it'd be a whole bunch of 45s. How many 45s? 4, 5, 6, 7 45s. So if you gave a big angle of 7 times 45, that would have worked. So negative 8 comma, whatever 7 times 45 is. Let me do it here. No, that's not right. 315. There we go. So 315 degrees, or negative 8 comma, if I did it in a big number of radians, that would be 7 pi over 4s. Very good. Those would all be correct answers. Okay, so that's how you take polar and make them have negative r's or negative angles. So many different things to know. A quick review of vectors, the stuff you just had. So imagine for a moment you had this. I did already warn you that the test is got a little bit more vectors than would be fair, so to speak, because it's only 1 out of like 6 chapters. But we actually did that to try to make your life better, because vectors are actually pretty fresh in your mind. You just had the test on that. But that does beg the question, is there any topic of vectors that you weren't good at? If so, now would be a good time to ask. Like, do you know how to do a unit vector? Do you know how to find something in the same direction as this? Do you know? Yes. Okay. There's a formula for that. Let's start with that. There's a formula that has cosine in it, and that would be, what's that formula for? Finding the angle between a couple vectors. So let's do that. Let's say we have 0, -2, 1, and I want to find the angle between these two vectors. My first thought is just a real quick test, because we are kind of obsessed with parallel and perpendicular. They're not the same, so this isn't parallel vectors. But could they be perpendicular? 1 times 0 is 0. 2 times -2 is -4. And 4 times 1 is +4. The dot product is what? 0. What does that instantly mean about it? They're perpendicular, and therefore the angle must be 90. And what's that formula again that goes with this? In case it hadn't worked out so nice. A dot B, magnitude A, magnitude B, cosine of theta. Yes. All right. So I know which problem you were talking about on the review test, I guess you'd say. Next person, come on out. So if the next if I wanted you to tell me the angle, you could use this to tell me the angle that's between the two vectors. Then from there, if I just needed cosine of that angle, if you tell me that the angle is 47.3, because you find that out from the formula, then cosine of 47.3. You just have to find the angle. How do you find the angle? How do you find that angle? Because once you do that, if you want cosine of the angle, that's super easy. So just find the angle first. How do you find the angle? I do this process. A dot B, which we already did with this one. The A dot B came out to 0. That's why we were instantly done, and we knew that. So what was the angle? The angle was 90. So then, technically, if this had been the problem, I would have figured out what cosine of 90 was. All right, but let's say we had two different vectors, 1, 3, 1, and 1, 2, 2. What's the angle between those two vectors? I'll pause for a second, give you a chance to try that. Angle between two vectors. There's lemon squeezy involved with this? Excellent. Okay, so I have done A dot B, and I got 9. And then I got square root of 11 and then square root of 9, which of course is 3. So then I'm going to divide both sides by root 11. And since the square root of 9 is 3, I'll just say 3 root 11. I'll do the same thing over here. And this cancels this. And now I have this weird looking thing, and then I do cosine of that. No, inverse cosine of that. So on my calculator, I do inverse cosine of 9 over 3 root 11. Personally, I'd put parentheses around this, because anytime I have two pieces in a fraction, I put parentheses there to keep the calculator from thinking, oh, so you want 9 divided by 3 times square root of 11. I'll do this part first. It's not supposed to do that part first. So I like to have this in parentheses. And then, inverse cosine of that. What did you get, sir?
25.24 degrees.
Everybody verify 25.24. Lots of people are shaking or nodding their heads. Good question. Let me answer it on the video here. So the question was, is that in radians? I'm going to tell you that since it says 25.24, there's no way that answer would be in radians, because that'd be 25 radians is so much. Radians are 60 degrees each. So what I'm trying to say is, can you look at your calculator's mode quick and see if you're in degrees or radians? Because I'm pretty sure this is the degree answer. All right. Yes. It'll say. If it doesn't say, we'd have to tell you. on the test. Or the question was, do we use radians or degrees on the test? Again, if it doesn't say, you get to pick either one. But usually, it's in a multiple choice question where you don't have a choice. You'll have to pick one of the choices in the multiple choice. All right. Okay. That covers a lot. It doesn't cover everything, but at least that plus what's in your packet should be enough, and I think you should do fine if you study all those things that I just talked about. If there's things on there you were like, didn't know what you were doing, go back and watch the video for it. There's a video for every single one of those things, like a full 30-minute video on how to do each of those things if you need it. Okay, so I hope that helped. Now, what we're down to, all we have left is on Monday, we'll grade your take-home. And that pretty much will eat up most of the hour. There might be a few minutes left for questions, but that's it. And then you take the final. What I would predict, just so you know, for big picture, most people are going to study some, and they're going to do okay, and they're going to, on average, normally, if you don't do anything abnormally, you study a little bit, and you come in and you take it, you'll do a little worse than your average. That's normal, because it's covering so much stuff. But because of the fact we use Marzano and stuff, you'll get a score that probably won't be enough to change your grade. You'll probably have the same grade you have right now. There'll be some people that will choose to just, like, I just can't do it. I can't study at all. I'm just not going to study, and I'm just going to take the test. And if that happens, there's a chance you'll do bad enough that it'll drag you down a half a grade. That's usually the worst case scenario, unless you're going to completely flat out fail the final. That'd be different. But if you just kind of do a little worse than normal, then the worst that usually happens is you go down a half a grade from whatever you do. And there's always a few people that just decide to kick some butt, and they really need this grade, and this is really important to them, and they study really hard for it, and since it's Marzano style, all you need is a 75 and a 75, and you can get an A. This is a doable test where you could get an A. And then you need that A to bring you up, and it can happen. So there's three kinds of people. People that are going to go down a half a notch, people that are going to stay the same, which is most of you, and people that are going to go up a half a notch and get that grade, but only because they try their butt off for the next few days. Last comment is for stuff that you want to turn in late. Remember, I don't take late work on a normal basis because I'm going to throw out your lowest two, and I haven't yet. So if you're looking at your grade saying, I wish it was a little higher, it will be because I'm going to throw out your lowest two. Okay, so that's why you get to throw out the lowest two, is because I'm not taking the late work. But if you have something you were absent for, you can still turn that in. And if you have a test you haven't taken, you can still do that. But those need to be done by, I was going to say Monday after school, but since there's a 2-hour help period on Tuesday morning, I'll also include that. So if you get it into me during that 2-hour help period on Tuesday morning, if you get everything done by then, I'll still take it. But anything after that, you missed the window to turn in to do old stuff. You can still take your final, of course, but any old stuff has to be done by Tuesday morning in that 2-hour morning help time. Okay? All right. There's always exceptions. If you have a special situation because you've been absent a ton, I'm sure it can be different for you. But if you don't talk to me about that, that's kind of the standard answer. All right. I'll wish you good luck. It helps me too if you get good grades in your final. So much easier to grade an A than it is to grade a C. And that's all I have.